Hello, and thanks for clicking on this Prenarchus production. Today, we're going to be talking about the properties of trig, part 3, the final in our 3-part series. Very exciting. We're going to talk about some trig identities, some other ones that you don't know yet, or you really do know. You maybe just don't know that you know them. And we're going to talk about what you can do with some of them. Okay? All right, so let's talk about some other trig identities right away. We know some of these at the top already. The sine of theta is 1 over cosecant, right? Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent is the reciprocal of cotangent. You could also write them the other way. Cosecant is 1 over sine. Okay? You could write secant is 1 over cosine. And cotangent is 1 over tangent. So those we pretty much already knew. These three here that I just wrote, but these are also true as well. You can write them that way also. Now, tangent is sine over cosine. We already know that as well because think about it. If we do it over here, the sine is the y-coordinate over the radius. Cosine is the x-coordinate over the radius. So if I keep this, I'll rewrite this, y over r divided by x over r. Keep that, change that, flip that over. Y over r times r over y, or r over x. R's cancel out, and I get y over x. But y over x, that's tangent. Y over x is tangent. So tangent is sine over cosine, the y-coordinate over the x-coordinate. Cotangent is just x over y, cosine over sine. So there's some other trig identities that you need to know. All right, we're going to use them coming up in just a couple minutes. Now, let's talk about this last set of identities, the Pythagorean identities. There are 3 Pythagorean identities, one that's easy, that everybody seems to know, and then 2 more that you can get from the first one. And if you can remember how to get them, you don't have to memorize them. That's how I do the second and the third identity. I don't know them off the top of my head. I just do them in my head when I need it. All right, so let's talk about what we have here. So let's go and let's draw ourselves a unit circle here real quick. Here's a unit circle. On my unit circle, if I were to pick out any point and make a triangle out of it. So this is my unit circle. If it's the unit circle, the radius is 1. And then I'm going x units across and y units up to reach this point up here. X across, y up. And then I know that, I know the Pythagorean theorem works. So x squared plus y squared equals 1 squared. So I know x squared plus y squared equals 1. Okay, that's all well and good. X squared plus y squared equals 1. But I also know something about the unit circle. I know that the sine of the angle is the y-coordinate, and the cosine of the angle is the x-coordinate on that unit circle. So instead of writing x squared plus y squared equals 1, I could literally sub in sine and cosine for x and y, and I could write cosine squared theta plus sine squared theta equals 1, or the way we normally see it, sine squared plus cosine squared equals 1. That is one of the 3 Pythagorean identities, number 1. Now there are 2 more. Okay, I can show you how to get them real quick. To get the second identity, what you do is take the first identity, take sine squared plus cosine squared equals 1, and divide all 3 of these by cosine squared and rewrite the trig function that you get. So sine squared over cosine squared, sine over cosine is tangent, so that's going to be tangent squared. Cosine squared over cosine squared is 1. 1 over cosine, that's secant, so that's going to be secant squared theta. That is Pythagorean identity number 2. And finally, if I go back to sine squared plus cosine squared equals 1, and I divide all three of these now by sine squared instead, sine squared over sine squared is 1. Cosine over sine is cotan. They're squared, so it's cotan squared. 1 over sine is cosecant squared. That is Pythagorean identity number 3. So, if you know the first identity, sine squared plus cosine squared equals 1, which for some reason is one that's pretty easy for folks to remember, and you know that if you take that identity, divide all 3 by cosine squared, you get the second Pythagorean identity. If you take all 3 and divide it by sine squared, you get this third Pythagorean identity. All 3 are identities you have to know. You can know them all off the top of your head, or you can say, all right, I'm going to know the first one, and I know how to figure out how to get the other 2, so I'm just going to do that if I need it. You can do that also. Okay? All right, so let's see how we're going to use these. So how are we going to use these identities? Here's what I want to do. I want to establish that sine of theta times cosecant of theta is equal to 1. So basically what I'm asking you to do is the following. I'm asking you to work on the left side, change the left side around so that your answer is on the right side. You get 1. So basically, it's like your dream question on a quiz. I give you the answer. Here's the answer, 1. You just show me how to get it. Okay? That's what we're going to do. So, we know that cosecant theta, cosecant is a reciprocal of sine, so cosecant's 1 over sine. So instead of writing cosecant, I'm going to swap it out and write 1 over sine in its place. So there's really a 1 underneath that sine. That gives me sine theta over sine theta. But sine divided by sine, they knock each other out. And I get 1. So I'm done. I did it. I showed that the two sides are exactly the same. In letter B, I want you to establish that 1 minus cosine x times 1 plus cosine x is equal to sine squared x. Well, this looks a little bit more complicated. Okay, I mean, it has cosine in it on the left side, but the right-hand side doesn't even have cosine. It has sine. So, what we're going to do is we're going to look to do something algebraic. Let's see what we can do. Well, we can multiply. So let's multiply because we have nothing else to do. And again, we're going to be practicing these a lot as we go forward. 1 times 1 is 1. 1 times cosine is cosine. Minus cosine times 1 is negative cosine. Positive times a negative is a negative. Cosine times cosine is cosine squared. All right, that has to equal sine squared. So cosine x minus cosine x, they knock each other out. That leaves me with 1 minus cosine x equals, or cosine squared x equals sine squared x. All right, now, I have an identity, the Pythagorean identity from the previous page, and it says sine squared x plus cosine squared x equals 1. Now, contained in this identity are 2 more identities, okay? One of them, if I subtract cosine squared on each side, tells me that sine squared is equal to 1 minus cosine squared. And then there's another one if I go back to the beginning and I subtract sine squared on both sides. I get cosine squared equals 1 minus sine squared. Okay? These are 2 more identities. So I have this one identity here, sine squared plus cosine squared equals 1. That's another identity, sine squared equals 1 minus cosine squared, just by subtracting cosine on each side. And then there's another one if I subtract sine squared on each side. Now, what I want to do is I want to trade 1 minus cosine squared into sine squared. Well, I can do that with this identity. 1 minus cosine squared is sine squared. So I can replace 1 minus cosine squared with sine squared. It's equal to it. And the 2 sides are equal. So this is done. Okay? So those Pythagorean identities that are on the previous page, right? They're a little bit deceiving because there are 3 identities over there. But really, in total, there are 9 identities. because if you just start subtracting things to the other side, you make other identities within this one identity. All right, so that's it. This is done. Okay, now finally we have the even and odd properties. Even and odd properties are based off of the unit circle, or easiest to see, I think, if you base it off the unit circle. So if you take a look at your unit circle, real quick, maybe you have one on you, you could look at it. What I want to do is I want to find the sine of a negative angle. Okay, now we know what that means. We also want to find the cosine of that negative angle and the tangent of the negative angle. All right. So we know what it means to find or what it means to have an angle that's negative. It means go clockwise. Okay. But what we're going to do is we're going to look in two quadrants to do these properties. We're going to look in quadrant 1 and we're going to look in quadrant 4. Take a look on your unit circle at your points that are in quadrant 1. Let's just look at one of the points just to make it a little bit easier on ourselves. Let's look at, let's say, the 45-degree angle point. So 45 degrees, or pi over 4 in quadrant 1 is root 2 over 2, root 2 over 2. In quadrant 4, that same reference angle would be, well, I'm going right and down. So that's root 2 over 2, negative root 2 over 2. Okay? And now what I want to do is I want to compare these 2 points. Okay? These 2 points with their respective trig functions. Now we understand that sine is the y-coordinate, cosine's x, and tangent's y over x on the unit circle. Let's do cosine first because it's the easiest of the 3. Cosine of negative theta. Well, cosine's the x-coordinate. The cosine of that negative angle, if I go clockwise, is root 2 over 2. In quadrant 1, it's also root 2 over 2. These answers are exactly the same. So it doesn't matter if I take the cosine of negative theta, if I go clockwise, or if I go counterclockwise to theta. Here's negative theta, here's theta. If I go clockwise to theta, so the cosine of negative theta, the x-coordinate in quadrant 4, is the same as if I went to the x-coordinate in quadrant 1. They have the same answer. These two are equal. However, for sine, that's not the case. Sine is the y-coordinate. So the y-coordinate in quadrant 4 is negative. But the y-coordinate in quadrant 1 is positive. So if I want to go to quadrant 4 and I want to compare my answer to quadrant 1, these two answers are not the same. The answer in quadrant 1 is the opposite of the answer you'd get in quadrant 4. In quadrant 1, the answer is positive. But in quadrant 4, the answer is negative. These two answers are opposite of each other. Okay? And then tangent, it's the same as sine. Tangent is y over x. So now, if I take the y, divide by the x in quadrant 4, I'm going to get negative 1, right? One of them's negative, the other one's positive. But in quadrant 1, if I divide them, they're both positive. So that's going to give me positive 1. So in quadrant 4, compared to quadrant 1, in quadrant 1, the answer is positive. In quadrant 4, the answer is negative. So the two of these answers are opposite one another. They're the opposite. Now, the reciprocal functions are the same. So cosecant of negative theta is negative cosecant theta. Secant of negative theta is let's erase the whole thing and start again. The secant of negative theta is equal to the secant of theta. And then the cotangent of negative theta is negative cotan theta. Okay? Now, some people remember it like this, which is fine. You can remember it like this, but that's easier. This is how it works out. This is how we get these answers. It comes from quadrant 4 and quadrant 1. Okay, comparing the two answers. All right, but some people do it this way. If I'm asking you for the sign of a negative angle, you can just stick the negative out in the front and then do the sign of the angle. The cosine of negative theta, you just drop out the negative because it's the same as cosine theta. And the tangent of negative theta, you can take the negative, stick it out in the front, and it gives you negative tan theta. All right, we're going to see how this works in just a second. Okay, that's how some people remember it, and that's fine. You can remember it like that too. If that's easier for you, that's more than fine. All right, how can we use these identities? I want the sign of negative pi over 4. So I'm asking you for the sign of negative pi over 4. Well, I have this even odd property that says the sign of negative theta is equal to negative sine theta. So this negative comes out into the front. So sine of negative pi over 4, the negative comes out into the front, would be negative sine pi over 4. Oh, well, now I don't have to go clockwise anymore. I could just go to the regular pi over 4 on my unit circle. Pi over 4 on the unit circle, pi over 4, that's root 2 over 2, root 2 over 2. Sine is the y-coordinate, so I'm going to do the negative of the y-coordinate, negative root 2 over 2. That's my answer. That's what sine of negative pi over 4 is equal to. Let's try cosine of negative 7 pi over 6. So cosine of negative 7 pi over 6. Well, the even odd property says cosine of negative theta is equal to cosine theta, which means the negative you can literally just drop off. So instead of doing cosine negative 7 pi over 6, I could just do cosine 7 pi over 6, which is on my unit circle. Cosine's the x-coordinate. You can do this with, like I said, reference angles, however you want to do it. Multiply by 6. This is 6 pi over 6. And then I'm going to have to go another pi over 6 forward. So that puts me here in quadrant 3. The reference angle is pi over 6. The angle at pi over 6 is root 3 over 2, 1/2. But I'm in quadrant 3, so that's negative root 3 over 2, negative 1/2. So the cosine of 7 pi over 6 is the negative, or is the x-coordinate. That's negative root 3 over 2. That's the answer. So these even odd properties can help you to avoid having to go clockwise on the unit circle and then figure out where you are relative to the actual unit circle. Or it could also keep you from having to add 2 pi to this angle, right, to figure out where you are in a positive unit circle. Okay, you can use these for that. All right, and that's it. And as always, thanks for clicking.